Space and Science News. With James. Picture our sun, the giver of life, the blazing heart of our solar system. For centuries, humanity has tracked its rhythms, studied its fiery flares, and basked in its warmth. But what if I told you our sun might harbor a hidden, catastrophic potential, one that could unleash chaos on a scale we can barely comprehend? Today, we're delving into a phenomenon so extreme it redefines what we thought stars like ours were capable of: superflares. These are not your average solar flares. They're cosmic explosions so massive they make our sun's usual outbursts look like sparks from a campfire. Now, imagine this: an eruption of energy so incomprehensibly vast that it could fry every satellite in orbit, melt power grids across continents, and hurl humanity into a technological abyss. No internet. No electricity. Just silence, broken only by the crackle of panic. Here's the twist: recent research suggests these terrifying events might be far more common than we've dared to believe. It's a realization that raises a chilling question: are we overdue for one? And yet, buried within this grim possibility lies hope. Could understanding these stellar time bombs hold the secret to protecting our fragile civilization? Or are we merely spectators, helpless against the sun's hidden fury? Let's peel back the layers of mystery and venture into the realm of superflares, where the line between life and destruction is far thinner than we ever imagined. In the vast expanse of our galaxy, our sun stands as a beacon of life, providing the energy that sustains our planet. For centuries, we've observed its rhythms, its sunspots, and its occasional flares. But recent discoveries have unveiled a phenomenon that dwarfs anything we've witnessed from our home star: superflares. These colossal eruptions of energy, observed on stars similar to our sun, have sent shockwaves through the scientific community and forced us to reconsider the potential fury hidden within our own star. Imagine a solar flare, but magnified to an almost unimaginable degree. That's what we're dealing with when we talk about superflares. These events release energy equivalent to more than 1 trillion hydrogen bombs, making them thousands of times more powerful than the largest solar flares ever recorded. The implications of such an event occurring on our sun are both fascinating and terrifying, prompting scientists to delve deeper into this cosmic mystery. In this video, we'll explore the groundbreaking research that has brought superflares to light, examine their frequency and potential impact on Earth, and consider what this means for our understanding of stellar physics and space weather forecasting. Join us as we unravel the secrets of these stellar explosions and contemplate the hidden power of our sun. At the heart of our newfound understanding of superflares lies an extraordinary study published in the journal Science on December 13, 2024. Led by the Max Planck Institute for Solar System Research, MPS, in Germany, an international team of researchers embarked on an ambitious project to uncover the true nature of these stellar explosions. Their approach? To turn their gaze not just to our sun, but to thousands of sun-like stars scattered across the cosmos. The cornerstone of this groundbreaking research was NASA's Kepler Space Telescope, a marvel of modern astronomy that spent years peering into the depths of space. Kepler's mission was to detect exoplanets by observing minute changes in the brightness of stars. But in doing so, it also captured a treasure trove of data on stellar behavior, including the telltale signs of superflares. The research team meticulously combed through data from 56,450 sun-like stars, observed over a 4-year period. This vast dataset provided an unprecedented window into stellar activity, equivalent to observing 220,000 years of stellar behavior. The sheer scale of this study allowed scientists to build a statistical model of how frequently these extreme events occur on stars similar to our sun. Selecting the right stars for this study was crucial. The team focused on stars with surface temperatures and brightness profiles closely matching those of our sun. They then embarked on the painstaking process of analyzing each potential superflare event, carefully ruling out false positives caused by cosmic radiation, passing asteroids, or nearby flaring stars. The results were staggering. Out of the 56,450 observed stars, the team identified 2,889 superflares occurring on 2,527 different stars. This led to a startling conclusion: on average, a sun-like star produces a superflare approximately once every century. This frequency is significantly higher than previous estimates, which had suggested intervals of thousands or even tens of thousands of years between such events. Dr. Valery Vasilyev, the study's lead author, expressed the team's astonishment at their findings. "We were very surprised that sun-like stars are prone to such frequent superflares," he stated, highlighting how this discovery challenges our previous understanding of stellar behavior. The implications of this study reach far beyond mere academic interest, forcing us to reconsider the potential for extreme solar events in our own solar system. To truly appreciate the significance of superflares, we need to delve into the complex physics that drive these extraordinary events. At their core, superflares are extreme manifestations of the same processes that produce regular solar flares, but on a vastly larger scale. Understanding these mechanisms is crucial to assessing the potential for such events on our own sun. Superflares, like their smaller counterparts, are powered by the sudden release of magnetic energy stored in a star's atmosphere. This energy builds up over time as the star's differential rotation winds up its magnetic field lines, much like twisting a rubber band. When these magnetic field lines become too twisted, they can suddenly snap and reconnect, releasing an enormous amount of energy in the process. What sets superflares apart is the sheer scale of this magnetic reconnection. Dr. Alan Sasha Brunn, a co-author of the study from the Commissariat of Atomic and Alternative Energies of Paris-Saclay, explains, high-performance dynamo computations of these solar-type stars easily explain the magnetic origins of the intense release of energy during such superflares. These computations suggest that sun-like stars can, under certain conditions, generate magnetic fields much stronger than what we typically observe on our sun. The energy released during a superflare is primarily in the form of electromagnetic radiation, spanning the entire spectrum from radio waves to gamma rays. This radiation burst is often accompanied by the ejection of charged particles and plasma from the star's atmosphere, known as a coronal mass ejection, CME. When directed towards a planet, these CMEs can interact with its magnetic field and atmosphere, potentially causing significant disruptions. One of the most intriguing aspects of superflares is their potential to accelerate particles to near-light speeds. These high-energy particles can produce secondary effects, such as the creation of radioactive isotopes in planetary atmospheres. This phenomenon has allowed scientists to study past solar events by analyzing the concentration of isotopes like carbon-14 in tree rings and ice cores. As our understanding of superflares grows, so too does our appreciation for the complex interplay of magnetic fields, plasma physics, and stellar evolution that make these events possible. This knowledge not only sheds light on the behavior of distant stars but also provides crucial insights into the potential for extreme events in our. The discovery that superflares occur roughly once per century on sun-like stars raises pressing questions about the potential impact on Earth if our sun were to produce such an event. While there's no evidence of a superflare occurring on the sun in recorded history, the new findings suggest that our star is likely capable of producing one. This possibility has significant implications for our planet and our technology-dependent civilization. To understand the potential consequences, we can look at historical solar events and scale up their effects. The Carrington event of 1859, often cited as the most powerful solar storm in recent history, caused widespread disruption to telegraph networks across Europe and North America. Auroras were visible as far south as the Caribbean, and some telegraph operators reported being able to send messages even after disconnecting their power supplies, solely using the current induced by the solar storm. Now, consider that the energy released during the Carrington event is estimated to be only about 1/100th of a typical superflare. The potential impacts of a true superflare hitting Earth are sobering. Such an event could cause widespread blackouts, disable satellites, disrupt GPS and communication systems, and potentially damage electrical grids beyond quick repair. The economic impact could be catastrophic, potentially costing trillions of dollars and taking years to fully recover from. Beyond the technological impact, a superflare could also pose risks to human health, particularly for astronauts in space or passengers and crew on high-altitude flights. The increased radiation could also affect the ozone layer, potentially leading to environmental and health consequences on the ground. However, it's important to note that Earth's magnetic field and atmosphere provide significant protection against solar events. Much of the energy and particles from a superflare would be deflected or absorbed before reaching the surface. Nonetheless, the sheer scale of a superflare means that even a fraction of its energy reaching Earth could have severe consequences. Dr. Natalie Krivova from the MPS emphasized the significance of these findings. The new data are a stark reminder that even the most extreme solar events are part of the sun's natural repertoire. This realization underscores the critical importance of developing robust space weather forecasting capabilities and taking steps to protect our infrastructure. As we continue to rely more heavily on technology and expand our presence in space, understanding and preparing for extreme solar events becomes not just a scientific pursuit, but a matter of global security and technological resilience. The study of superflares serves as a crucial wake-up call, prompting us to consider how we can safeguard our modern civilization against the awesome power of our home star. As we grapple with the implications of frequent superflares on sun-like stars, scientists and policymakers are already looking ahead to improve our ability to predict and mitigate the effects of extreme solar events. This final explores the future of solar research and the strategies being developed to protect our planet from the sun's potential fury. One of the most promising developments on the horizon is the European Space Agency's Vigil mission, set to launch in 2031. This innovative space probe will provide a new vantage point for observing solar activity. Positioned to the side of the Sun-Earth line, Vigil will be able to detect solar storms and coronal mass ejections days before they reach Earth, potentially offering crucial early warnings of dangerous space weather. In addition to space-based observations, researchers are working to improve our understanding of the Sun's internal dynamics. Advanced computer models are being developed to simulate the complex interplay of plasma flows and magnetic fields within the Sun, aiming to predict the conditions that might lead to a superflare. These models, combined with ongoing observations, could help us anticipate periods of increased solar activity and the potential for extreme events. Efforts are also underway to enhance the resilience of our technological infrastructure. Power grid operators are implementing strategies to rapidly disconnect and protect critical components during severe solar storms. Satellite designers are exploring ways to shield sensitive electronics from increased radiation levels. And telecommunications companies are developing redundancy and quick recovery systems to maintain connectivity even in the face of solar-induced disruptions. On a global scale, space weather forecasting is becoming an increasingly important field. International cooperation is crucial, as a superflare would affect the entire planet. Organizations like the World Meteorological Organization are working to standardize space weather observations and alerts, ensuring that countries around the world can respond quickly and effectively to solar threats. Education and public awareness also play a vital role in our preparedness. As we learn more about superflares and their potential impacts, it's crucial to communicate this information to the public, policymakers, and industry leaders. Understanding the risks allows for better planning and resource allocation to mitigate potential damages. While the prospect of a superflare from our sun may seem daunting, it's important to remember that our increasing knowledge and technological capabilities put us in a better position than ever to face such a challenge. The study of superflares on other stars has provided us with invaluable insights, allowing us to anticipate and prepare for possibilities we might never have considered otherwise. As we continue to explore the mysteries of our sun and its stellar cousins, we move closer to safeguarding our technological civilization against the awesome power of stellar fury. The journey of discovery continues, driven by human curiosity and the need to protect our home in the cosmos. The phenomenon of superflares reveals a captivating yet concerning facet of stellar behavior. Our sun, while seemingly calm and nurturing, has the potential to unleash energy on a scale that could disrupt our technological civilization. The research highlighting the frequency of these events among sun-like stars challenges our previous understanding and emphasizes the need for vigilance in monitoring solar activity. Understanding superflares is not just an academic pursuit, it has real-world implications for our infrastructure and daily lives. The possibility of a superflare impacting Earth reminds us of the delicate balance we maintain with our environment and the cosmic forces at play. As we advance our technology and deepen our exploration of space, it becomes increasingly important to develop robust systems for predicting and mitigating the effects of extreme solar events. Thank you for joining us on this journey into the hidden fury of our sun. If you found this video enlightening, please consider subscribing to our channel for more intriguing insights into the mysteries of the universe. Your support helps us continue to explore these captivating topics and share them with you. Don't forget to hit the notification bell so you never miss an update. We'd love to hear your thoughts on superflares in the comments below. What do you think about the potential risks they pose? Until next time, keep looking up at the stars, and stay curious. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.